Hi, I'm Mr. Kangas, and today we're going to be taking a look at Chapter 12, Section 6, Misleading Graphs. This shouldn't be a very long video. It's not a difficult section to explain. Basically, you're going to be looking at different graphs of the same data, and you're going to be determining which graph is actually the misleading portion. Which graph is misleading. There are different ways to mislead people with graphs, but one of the most common ways you're going to see is by manipulating what is known as the vertical scale. And that is the scale or the numbers that go up the left side of the graph here. What you're going to notice in graph 1 and graph 2 is one of them starts all the way down at 0, while the other one starts at 950. So while this vertical scale spans 1,000 intervals, this vertical scale is only spanning 50 intervals. So the data is going to look significantly different. This graph looks like it is relating the number of votes that people made as to what their favorite food was. And so it looks to me as though pizza had roughly 975 votes. Hot dogs had right around 985, 990 votes. And hamburgers had about 955 votes. So it looks like there were almost 3,000 people that voted. Pizza, hot dogs, and hamburgers all really... The number of votes they received was pretty similar. I mean, one food did not blow any of the others out of the water. It's not like hot dogs. Even though hot dogs had the most votes, hot dogs didn't win this vote by much. I mean, if you look at hot dogs, they had about 987 people vote for that. Pizza was at 900 and roughly 72, 73. So you're literally looking at like a 10 to 15 vote difference between pizza and hot dogs. And even if you want to take hamburgers into effect, I mean, hamburgers were only off by about 30. And when you consider that almost 3,000 people voted on this, missing out by 30 votes is not a lot. Okay, so which graph would be misleading? That would most definitely be this graph 1 if you haven't figured that out already, because graph 1 makes it look like hot dogs won this vote by a landslide, when in reality this was a roughly 3,000 person vote, and the hot dogs only won the vote by about 15 votes, which isn't many considering the amount of people who voted. And the reason why it looks like such a landslide is because their vertical scale didn't start at 0, so it wasn't really an accurate depiction as far as the visual goes. The graph does not look like it should because it's not starting at 0, it's starting at 950. So what this is doing here is basically... you only have 50 intervals, so when you're ahead by 15 or 20 in a graph that only has 50 intervals, well, 15 to 20 votes in a 50 interval graph is roughly 35 to 40% of the graph. So I mean, that space between pizza and hot dogs is roughly 35 to 40% of your graph, whereas over here, that 15 votes isn't going to be nearly as much because you're going from 0 to 1,000, so you have 1,000 intervals. And so this is a more accurate depiction. As you can see, I mean, this graph makes it look like it was a close vote, whereas this one makes it look like a landslide. And so typically, if you want to see an accurate depiction of something, you typically are looking for the graph that starts at 0. There are other ways to mislead people, but this is probably the most common way, is you basically only take a look at the top end of the graph and you take that vertical scale and you reduce it significantly. We went from 1,000 intervals over here in graph 2 to 50 intervals over here in graph 1. I got another picture over here where you have three different graphs that have three slightly different vertical scales. You'll see that this graph, the graph 1, goes from 0 to 800. Because the max is only 600, this graph went from 0 to 800. Over here, this graph went from 200 to 1000. So this graph did not start at 0 here in graph 2. And down here in graph 3, we're going from 0 to 800 again. Does not. Capacity in pounds, capacity in pounds.